Okay, so the next example that I want to share with you today is we want to evaluate the double integral where the region is a non-rectangular region which is bounded should be bounded by a circle radius 2. Okay, so now when we sketch the region, so on y-axis plane, so we have a circle with radius 2. Okay, and center at the origin. So we have a complete circle. Okay, full. So our region is a circle. So now we want to solve that. We want to evaluate that. 4 minus y. Okay, the equation that we have is x squared plus y squared equal to 4. So now you have to decide which order of integration that you want to choose here. So firstly, you have to look at your integrand. So only 4 minus y, so we have no problem if we want to integrate respect to x first or respect to y first. So let's say I want to have just maybe x constant. So maybe x constant, so y function, so dy dx. Okay, so now we want to get the limit of x and the limit of y. So x constant. When x constant, then we have to provide the vertical line. Okay, vertical line. You can provide many lines just to make sure that all the time we have the similar lower bound and the upper bound for x and y. Okay, so now x. As you can see here, our region here is a complete circle, and that one 2, so this is supposed to be minus 2, right? So now you can see that the lines, only single line or all the lines are lying between minus 2 to 2. Okay, and then y is a function, so there is no a function in terms of x, just x squared plus y squared. So in this case, you have to rearrange and you have to have y equal to plus minus 4 minus x squared, and the square root of 4 minus x squared plus minus. So meaning that what we can say here, positive square root means for y positive, so the function is positive 4 minus x squared, so this is y. And for down here, it belongs to y negative, right? So then we have y equal to negative of the square root of 4 minus x squared. So now we want to find out the limit of y. So now, how can we determine the limit of y? So we imagine that you are walking down here and you're moving upward along the x-axis. So you're walking slowly. So let's say we refer to this vertical line, or you can also refer to this vertical line. So this is the first point, or you have the point here. So all the points, they are all belongs to the curve of because this belongs to the negative of y. So we can put the negative square root minus 4 minus x squared. Okay, and then keep going upward. So this is the terminal point, or this one, or you can put very many points, and all these points are lying on the, or belongs to, positive square root. So y equal to positive square root of 4 minus x squared. Okay, so now we already obtained the limit for the x and the y. Okay, so now x is minus 2 to 2, and then y is negative square root 4 minus x squared, and this is positive square root 4 minus x squared. So now it's time for us to integrate. So firstly, we want to integrate respect to y. Okay, so we have 4y minus y squared over 2. So we have to put the limit of y, negative square root 4 minus x squared and y positive square root 4 minus x squared dx. So you have to make sure that all your terms they are in terms of only x after you replace the y. So then we have to substitute for the positive square root. So for y minus 1 over 2, 4 square root 4 minus x squared minus 1 over 2, 4 minus x squared. Okay, and then minus, so now we have negative, so minus 4 square root 4 minus x squared minus 1 over 2, 4 minus x squared dx. So now you need to simplify. Okay, so when you expand and simplify, so you can there are some terms can be cancelled out. Okay, this one negative minus 2 plus 2 cancel out. Half of x squared minus half of x squared also cancel out. So this one we just total up, so you get just this one. Okay, so now you want to integrate this one with respect to x. So tell me, what is the most appropriate technique of integration can be applied here? You cannot use the by parts because this one there is a square root, and also you cannot use the regular substitution because why we need the substitution? You want to simplify the form, right? But I'm sure that if you try to use the let 4 minus x squared, and your expression becomes more messy. So that is not the option. Okay. Actually, for this one, if you have the square root and there is no other expression outside, and also and the possible technique of integration that can be applied here is using the substitution. What we have a special substitution where it is called as a trigonometric substitution. Okay, so what is a trigonometric substitution? So you have to assume that instead of you just have u equal to maybe 4 minus x squared, but this one doesn't work because your expression becomes messy. So we can use the trigonometric substitution. So for that you have to use the identity of trigo, where you have the cos square a plus sine square a is equal to 1. Okay, so now you can see the 4 minus okay, if you remember the general form of the trigonometric substitution, then you can easily find out what is the most appropriate substitution in terms of trigonometric equation here, because maybe some of you memorize that. Okay, but then if you don't remember that, we have to go back to the basic where you were using this identity. So we want to have, because you can see that you have 4, right? You have 4. So it looks like what we can do is, okay, you can see the 4 here, right? So we want to convert this into a trigonometric function. Okay, maybe you will get a sine, cos, or maybe tangent. Okay, so it depends on whatever you will get after you substitute using the trigonometric substitution. But how can you know the possible trigonometric equation that you have to put as a x to replace the x? Okay, so to get that idea, if you don't remember that, maybe some of you just you do some memorization, because when you learn the engineering math 1, so I'm sure that you have seen this. Okay, so and then how actually it's work. So using the basic identity here, so we can see number 4, right? 4. So now we just multiply both sides by 4. So you have this one. And then because you want to have 4 minus, so you bring one of them to the other side. So in this case, I bring the sign to the other side. And maybe some of you use a cos, so it depends on whatever your understanding. Okay, but in this case, you can use both, whether sine or cos, because still we get the at the end we will get the similar answer. But in this case, I bring the sign to the other side, so 4 minus 4 sine square A. So now I want to relate the form here to be the thing that we want to replace over here. So you can see that now 4 minus 4 sine square A have the same pattern as 4 minus x squared. So now in this case, I will let, okay, now from there, what we can have is x squared is equal to 4 sine square A. So meaning that what I can have is what I want it x to be 2 sine A. So this is the assumption that I want to have, x equal to 2 sine A. So and then you have, meaning that you are using A. Maybe some of you use a theta or B, whatever, as long as it is not no longer x, because you want to replace x to be another form, and another variable. Okay, in this case I'm using A. Okay, so now you will replace 4 minus x squared, so you have a 4 minus 4 sine square A, okay, which is this one. So from here, because of you will have then you need to square root, right? You can see that you need to square root 4 minus x squared. You have to put the square root both sides. And then when you square root the left side, so this one you can do nothing. It's just like this. But on your left side, you can simplify. You will get to cos A. So now you can have your new form is the square root of 4 minus x squared is equal to 2 cos A. Then you have to replace the dx here in terms of A. So you have to differentiate this one. So dx dA is 2 cos A. So your dx is 2 cos A dA. Then you have to replace this here. So multiplied by 2 cos A dA. So now everything now is in terms of A. Then 16. Then you have a cos square A dA. Okay, so now still you cannot directly integrate, but you can integrate. Okay, so what in the integration of cos square A dA? Will you give me cos cube A over 3? If you give me that the answer like that, so it's totally wrong. So this is not just a function. Like say you have a simple expression x squared. When you integrate x squared, then you will get x cubed over 3. So that is correct. But this one, there is a function in a function. The outer function is square, and the inner the outer function is the outer function is square, and the inner function is cos. So you cannot directly integrate like this. So you have to reform this into if you have square here, you have to reduce the power first using another identity of trigonometry. Okay, so since I know that all of you have done this in GMAT 1, so I'm not going to solve that for you. So you have to find it yourself. And you will need some more steps, which is maybe 3 or 4 steps in order for you to get the answer, which is not I don't want to say it is complicated. No, it is not complicated but tedious. So there are so many steps that you have to figure out. Okay, but still can be done, but you need more steps. And finally, your answer will be, you will get 16 pi. Okay, you have to substitute the you will substitute the limit of x and y here, and your final answer should be pi. Okay, why we have a pi here? Actually, when you proceed this one, okay, so maybe it is good for me to just give you not only the final solution, but just part of the expression. So after you done the substitution, you have to reduce the power here, and then after that you have to integrate then, and you will get, so you need some more step, and you will get the expression in terms of x will be, so it looks messy, x over 2 multiplied by 4 minus x squared, which is there is a square root, divided by 2 plus, okay, plus you have the inverse sign, arcsine of x over 2. So the limit from minus 2 to 2. So how can you have the pi here? Because you have inverse function. You have the inverse sign here. When you replace the value of 2 and minus 2, and you will get the answer is in terms of radian, or if you set in the radian, so your answer will be pi. Okay, but normally, as I mentioned before, when you do the sum calculation, so we always use the radian. Okay, so you have to bear in mind during using for when you do the computation or calculation, so always use radian. Otherwise, your final answer will be different and it is wrong. So show me that you will get the 16 pi. If you can get it, and please let me know, or you have to just do extra revision on the trigonometric substitution. So in this case, the process here is not the double integral itself. I mean, it's not to getting the limit and the order, but this one is need your ability to integrate. Okay, which means that you have seen that when you are doing the engineering maths 1. Okay, so for the engineering maths 2, the new thing that you have learned here is this part. Okay, so that's why I told you before. If you feel that integration method or technique still you still feel that one is confusing you, and you have to do a lot of exercises and revision. Otherwise, I'm sure that you will feel that this topic is very complicated for you. Okay, so actually, okay, so as you can see here, the process is quite complicated and tedious. Okay, maybe some of you feel this is okay. Yeah, this is okay for me. Okay, but not for some of you. And maybe some of you feel okay, but not for all of you. Okay, some of you feel this is very complicated. Actually, there is another way which more simpler, which means that we don't proceed in the Cartesian coordinate. So we call this, when you deal with the x and y, so or z, x, y, z, so we call that as a Cartesian. Okay, Cartesian coordinate. Okay, when you deal with the x, y, and z, we have a Cartesian coordinate. Okay, but in order for you to obtain the solution for this particular question more easier, you can transform this into another coordinate system where we call that as a polar coordinate, where we don't use the x, y, z anymore, but you have to deal with the r and theta. So I'm sure that you ever heard of the word of polar, right? When you were taking the engineering 1 last semester. So now we want to apply that particular coordinate again in this multiple integral. Okay, so the next is we want to learn on how can we use the polar coordinate in the double integral. Okay, so that is our next objective. We want to learn how to integrate or transform the Cartesian equation into polar equation, where from xy you transform to r and theta. Because why we need that? We need that because for this particular question, it is quite in terms of integrating to do the integration here, it is a bit complicated. Okay, but still can be we can obtain the solution, but you need some extra steps. Okay, rather than if you convert this into polar, you can solve in just a few steps only, with the condition that you know how to convert. So now that is our aim. We want to know how to convert. Okay, so we will get back to this example after you understand how to use how to convert the from Cartesian into polar coordinate system.